this is the last video of Unit 1 Part 2, and here I'm talking about the overlay of sound waves. So what does that actually mean? In practice, we will always have more than one sound wave at one point in space, at one point in time, because when even just one instrument plays, there is many sound waves traveling through the air. So all of these sound waves somehow exist at the same point in time, at the same point in space. So here I want to explain you what does happen when multiple sound waves occur at the same point. So let me draw a little graph for you here. So this is the amplitude, and this is the time, and we got our first sound wave, something like that, and then we got a second sound wave, which is something like that. So the second sound wave has a much higher frequency than the first one, and now the question basically is, what is happening with the two sound waves in reality, in physics? So what happens is they will basically summed together. They will just be summed together. So at every point in time, we just take the sum of the two waves. So it will go like first up a little more, and then they will cancel each other out. Then they will sum up again. Go much lower down at this point. Probably not the best drawing I did so far, but something like that. Huh? So we just always, at every point, we just take the sum of the 2 points. And this is then the red line is basically what we end up with. So now we can already see some like if there is occurring some strange composition of different sound waves, we can get strange effects. So for instance, one example is as follows. So we have again a sound wave here, and we have the exact same sound wave again, but just shifted by 180 degrees. So it's just exactly the opposite of the other wave. So what is happening when these two sound waves occur together? So when we take the sum, I mean this is 0, this is let's say +5, and this is -5. So whenever we take the sum of these, we will end up at 0. At every point in time, we will basically end up at 0. So the result of these two waves is 0, which means 0 volume. So these two sound waves, they cancel each other out completely, and we will end up with no sound at all. And this actually happens quite often in practice. The two sound waves just have an overlay which cancels each other out, or they might also have a partial overlay and just cancel out like some parts, let's say, of the frequency spectrum. And this is an effect we want to avoid. So this effect is called counter phase signal. So the phase is shifted by 180 degrees, and it says basically if two sound sources produce a signal with opposite phase shift, or a phase shift of 180 degrees, then the two signals cancel each other out, either partially, or if both have the exact same amplitude as I did the drawing before, they fully cancel each other out. Another very interesting effect I would like to explain at this point quickly is the comb filter effect. It's basically also a very special like overlay of different sound waves, and it mostly happens when the speakers are not set up properly. So therefore I have to do another drawing. So this is now the top view of a room. Let me do it in black. This is the top view of a room, and we got two speakers, one speaker here and another speaker here. Now, depending on the point where you stand, let's say you stand here, the sound of this speaker is approaching you much earlier than the sound of this speaker, because the speaker on the right has to travel, the sound from the speaker of the right on the right has to travel a longer distance. So basically, these two sound waves, they won't arrive at your ear at the same point in time. So that means the overlay of the sound waves of the two speakers could cause strange effects. I mean, both of the speakers play, let's say, the exactly same sound, but as they not arrive at the same point in time at your ear, you might get interesting effects. And one of these interesting effects is called the comb filter effect. So this is what it says here: if a point in the room receives a signal from two different speakers which both send the exact same signal, but the distance from the point to the speakers is not equal, as I drew it before, we get this comb filter effect. And basically what's happening is that at a certain frequency we will get this counter phase signal. So the two phases cancel each other out. So one certain frequency will be cancelled out. So this graph here shows, let me show you that. Yeah, so this graph here basically shows the volume of at every frequency from 20 or from 100 to 10,000 in this case. And what it shows here basically is that when the sound waves arrive at your ear, they might be good for certain frequencies, but at some frequencies they will start cancelling each other out, and the volume at that frequency will go down to zero. And then the interesting thing here is that at the exact, like when you double the frequency, this same thing will happen again. So when you go from 500 to, let's say, 1000, I think there is a little issue in this drawing. So when they cancel each other out at 500, they will cancel each other out again at 1000 hertz, and then again at 2000 hertz, at 4000 hertz, and so on. So whenever you double the frequency, they will cancel each other out again, and then in the end we get this comb-like volume curve, and this is why it's called the comb filter effect. So you should always try to make sure that every point in the room achieves as much as possible at the same point in time the signal of two speakers. If this is not, I mean, this won't be possible because you will only receive the signal at the same point in time when you are standing in the middle of the room, which is basically this line. But what you can make sure is that the speakers are set up in a way that basically the volume of the other speaker is low enough so that this comb filter effect will not happen. Because if one speaker has a much lower volume at a certain point, I mean, let's take this point again. So the volume of this speaker will be very low. So it might not cause this strange comb filter effect. So there's also a lot to consider in speaker setup, so that the areas where the speakers end do not overlay too much, so that we don't end up in this effect. Thank you for watching the video.